Games. Next generation gaming has started. So has next generation PC gaming. For Nvidia, PC gaming starts with GeForce. It is the heart and soul of PC gaming today. Not only is it the most advanced and most powerful GPU in the world, it makes possible and turns a PC into an amazing game console. We've also added to GeForce this application called GeForce Experience. It is a client and cloud-connected application that makes it possible for us to enjoy the PC in the glory of its scalability, but also be as well-behaved as a game console, as easy to use as a game console. On the one hand, whenever you add new CPU or new GPU to your PC, it recognizes its capabilities and extends automatically to the capabilities of that PC. So you can enjoy your games in a higher fidelity with more special effects, more realism. However, if your PC is not as capable, because of all the hard work we've done in the back rooms, and because of the cloud-connected applications, it self-detects and reconfigures the game so that you can enjoy it at the best possible frame rate. GeForce Experience has been downloaded over 20 million times. Gamers all over the world are really enjoying the benefits of GeForce Experience. That is the core of NVIDIA's PC gaming strategy, but that's not the end of it. Over the last couple of years, you've seen us extend the capability of the PC so that you can enjoy the wonderful graphics on any display that you like. We invented a technology called GameStream. GameStream is about streaming real-time computer graphics. Unlike YouTube, because computer graphics is interactive, there's very little time for you to control, change, recompute the scene, and have the scene returned back to you. You have very little time to do that and still be convincing that you're controlling the application yourself. The latency is of vital importance. So the concept of buffering is really not applicable to GameStream. Uh-oh, I feel like my voice is starting to go. That was 3 sentences, I think. All right. Could I have the water? Oh, thanks. This is good. Thank you. We're just with a bunch of friends. They're okay. Where was I? Game streaming. And so game stream is a technology that is incredibly difficult to do. And we've been working on this for some time. And I think we've done a really good job perfecting this. We still have a long ways to go, but it's absolutely delightful today. It makes it possible for you to enjoy and extend your PC experience to a mobile device. So we created a device called Shield. Shield and your PC could be connected wirelessly, and for you to enjoy the PC game literally on that Shield device, and as if the game is actually running on Shield. Using Shield in a game console mode, with its lid closed, you can connect it to a 4K television and stream 1080p 60 hertz video game right to the television. And you can now enjoy your PC on the television, as if the game console, as if the PC is directly connected to your game console, to your television. And then of course, because people like to share their greatest moments in games today, it's now possible for you to capture your gameplay and stream it to a service like Twitch. Twitch is the leading game broadcasting service in America. About 300 million gamers watch video games, watch other people play video games on the internet today. And about 40 million of them watch Twitch video games each month. It is now possible with your GeForce to capture your game, stream it right directly to Twitch without it affecting your frame rate at all. Really, really wonderful capability. So GameStream makes it possible for us to capture your game, stream it, and for you to enjoy it remotely. So why don't why don't we show it to you? Show you where we are with game stream technology. Sean, come on up and let's
Sure.
show them what we've got. So let me first explain the setup. You're going to enjoy a PC game, the latest generation PC game, DX11, called Batman. It's going to be enjoyed on this 4K television, okay, running 1080p, then scaled to 4K at 60 hertz. Now go ahead and launch it, Sean. The game is being streamed to this Shield device that's sitting right here. Okay, so this is Shield. Go ahead. So Sean is playing Batman. Now this is using our latest generation GeForce, and notice Batman has DX11, and so there's some special things in Batman. I mean, if you ever enjoyed Batman, it's got so much technology inside. The cape is a cloth simulation, so you can see, look at the cape. It interacts with your motion and Batman and all the characters looking. When the helicopter flew over it, the cape was being blown around. Notice the snow. Every time you walk over it, it actually deforms the snow, and it's deformed permanently. So, okay, so it's not some art, it's physics simulation. The lighting system is just fantastic. Now you're enjoying this, it's completely interactive, and Sean is controlling a PC that is wirelessly over here. So imagine this PC is in your bedroom, and so this PC is actually the game console for Sean right now. Okay, he's remoting access to it. The Batman game could be available on Steam. Steam is the #1 Play Store on PCs, and you can enjoy it streamed directly to him. You could see that, in fact, this game is being streamed. Can you guys see that? And the two screens are perfectly synchronized, as if there's no latency whatsoever.
It feels just like I'm at my gaming PC. So I can instead of lugging my giant gaming PC into my living room, I can enjoy the same experience in front of my TV.
So for some people who enjoys game consoles, they can obviously connect a game console to their TV. But if you already have PC gaming, as in several 100 million people around the world today, then you can now, with GeForce, with GameStream, and then with a Shield game console connected device, you can now enjoy next generation games on your television. Okay? Thank you. Now, Sean, we could that Shield was connected over gigabit Ethernet,
Right.
and it's streaming 1080p at 60 hertz. But there's no reason why we can't also stream it wirelessly, right?
Of course.
And so let's see. Look over your shoulders here. I think they're about to see. Can you guys see that? All right. So this is the same game, Batman. He could pick up where he left off. Now he's enjoying it on his portable device. This video game, of course, is unlike anything that's even remotely possible today on a mobile device, and now he can enjoy it in his handheld, in his Shield. Now this is being streamed at 720p, and this is the amazing thing. Now if he's at home, Sean could surely stream from his PC, right there. Okay, that's obviously something that's relatively easy for us to do. However, this is the fun part. Thank you. That's really great. This is the fun part. What's really fun right now is that this server that he was streaming from is actually in Sofia, France. Now what we've shown you here is the grid virtualized GPU server with the ability to serve, of course, games to hundreds of people at a time. Game streaming all the way across the ocean, 6,000 miles across the ocean, which in the speed of light is about 30 milliseconds. So the round trip delay, when Sean hits presses punch, the punch command goes 30 milliseconds across the ocean. It gets processed in the grid server. The frame is captured, compressed, and game streamed back 30 milliseconds later back to the Shield device. Now, for it to be completely interactive, and because we can notice anything about 200 milliseconds of latency, just imagine how little time we wasted to send the commands, to go through the servers, of course, all the different hops in the routers and such, to compress, to render the frame, compress the frame, and stream it all back. Okay? So that's game streaming. I want to talk about G-Sync. G-Sync is the latest buzz. We invented G-Sync to solve one of the longest running computer graphics challenges. This is a multi-decade problem. If you take a look at computer graphics today, no matter how hard we try, there's still stutter and lag. Now, stutter and lag comes from fundamentally the fact that there is no game or no application where the frame rate is consistent or constant across every single frame. The fact of the matter is, sometimes there's more explosion, sometimes there are more characters, sometimes there are fewer characters. And because now we have multiplayer games, because we have physics, it is now almost impossible for the game developer to know how to load each frame. Each frame could be very surprising. All of a sudden, multiple players showed up, tanks show up, explosions happening, and your frame rate drops. And so the challenge for us is to create a system that enables you to enjoy the video game as smoothly as possible. So you have fundamentally this GPU that's generating frames at a variable rate. Sometimes it could be as high as 100 frames per second. Sometimes it could be as low as 8 frames per second. On the other hand, the monitor is sampling. The monitor is sampling the frame rate at 60 hertz. The 60 hertz is a residue, if you will, a remnant of the way that CRTs were created a long time ago. We said to ourselves, why do we have to be governed by this historical architecture between the GPU and the monitor? So we decided to create something fundamentally different. And the idea is relatively simple. Instead of having two systems that are autonomous to each other, we should synchronize to the source of the frame generation. The GPU is generating the frame. We should update the frame whenever the GPU is ready. And that's why we decided to call it G-Sync. Now, before let us do this. Let us show you now these different methods of synchronization. I'll explain some more in just a second. And so, Tom, let's go ahead and start. So this is StarCraft. This is the most played video games in esports today. Millions and millions of gamers play StarCraft. This is one of the major games in esports with prize monies, multiple millions of dollars each year. This is a real-time strategy game where the gamer is managing assets, building their bases, partnering with other races, and of course conquering, attacking, defending. Okay, real-time simulation game. It's actually a rather technical game, very strategic game. In fact, schools even teach strategies based on real-time simulation games, based on StarCraft. One of the things that you see is that you're looking at an expansive world and you're going back and forth because you're managing your territory. Okay, and as you're looking at this, this is with V-Sync on, which is basically the monitor is synchronized at 60 frames per second, 60 hertz. And we only update the monitor whenever it is done with the vertical sync. That's why it's called vertical sync on. And you can see that every so often it stutters. And the reason for that is you're sampling the frames at 16 milliseconds. And every so often, you sample the same frame more than once because the next frame's not quite ready yet. okay, because the frame rate is so low. And that's why you experience this judder. All right, now you could solve this problem and you can make it smoother by adding more buffers. And people call it double buffering and triple buffering. But the problem with double and triple buffering is that you add latency to the system. The more you buffer, okay, the more you buffer, the more latency you add. And so most gamers, in this particular case, the gamers want so little lag because their ability to compete depends on how many clicks they can make per minute. And there are gamers that can actually strategically click 300 times a minute. And these are professional sports, of course. And so they turn off VSync, compromising visual quality so that they could be more competitive. Now let's show them VSync off. The lag from the mouse movement to the photons hitting your eyes has now been reduced dramatically. However, what's happening is you're seeing this tearing. The reason why it's tearing is because as soon as the GPU is ready, it starts sending the pixels to the monitor. The monitor could be only halfway through refreshing, and as a result, it captures half of the previous frame buffer and half of the next frame buffer, or some of the next frame buffer. And so as a result, you see that sharing or that tearing. So this is VSync off. It's much more low latency, less lag. However, you now have tearing that you're experiencing. So we invented this technology. The buzz is incredible. It's called G-Sync. Okay, let's go to G-Sync. Can you guys see that? So this is what's happening. As soon as the GPU is ready, we're updating the frame. Now, the notion of tearing is gone, but the lag is still incredibly low. As a result, you don't see the stuttering that usually comes with VSync on, and you don't see the tearing that comes with VSync off. Now, the buzz is incredibly high because we've been living with stuttering and lag for so long. John Carmack, who's the founder of id, says that this is once you've experienced this, you can't go back. And Tim Sweeney over at Epic said that this is as big of a deal as the first time he used iPhone. So people are really, really excited about this. In fact, we took it to a game conference recently, the StarCraft Red Bull Battlegrounds conference, and let's hear what they said about it.
Hey, I'm Andrew with Nvidia, and we're here in New York City for the Red Bull Battleground StarCraft 2 tournament. We had a chance to catch up with some of the world's top StarCraft 2 pros and show them our brand new Nvidia G-Sync technology. So what did you think?
It's fast and smooth.
Wow,
Really
okay.
great.
And it felt comfortable, no lag?
Yeah, no rag.
Awesome. And what'd you think?
Fuck you also.
Yeah, all right, I like that.
Esports. Now that gamer, his name is SK Parting. He is the world champion of StarCraft, and each year him and his team take home hundreds of thousands of dollars of prize winnings. Okay, so G-Sync, revolutionary new display technology. We're really, really excited about it. It's going to be available in Q2 from just about every monitor maker who target the gamers. Really excited about G-Sync. If you get a chance, I really urge you to take a look at it at our booth, and I think that we're going to have it available for you to take a look at on the side here after our presentation.